let's continue on what we will cover this week. So at the end of this week, you will be covering part of CLO2 actually, if you still remember what I explained in the previous video. So this is actually CLO2, course learning outcome 2, to analyze similarity and differences of image processing technique between different modality for different biomedical application. So here you will be exposed on the different type of images. What does it mean by X-ray images? What does it mean by ultrasound images? What does it mean by CT images and all that. So you will learn about imaging system and the fundamental of digital image processing, how the analog image being translated into digital image, and the medical application of it, where you will see mostly on this type of images. Okay, so these two video, the previous video overview of the class, this video is overview what we'll cover in first week of the lecture. Okay, during the lecture, the physical lecture, later on you will do class activity, and also you will be exposed to the different types, and also different types of imaging modality and how is it different, which one will be used for certain application. You will learn about that, okay, before we go into the image processing and MATLAB. MATLAB exercises we will do in the second week. All right, let's look at this video, okay? So this is the colored image, or in the image processing, we call it as index images, yeah? Where you see that there's a blue color, red color, orange color, and all that. And this color determine the area of the body where if the certain part of the body has high temperature, the color will be red. So throughout the class, you will learn that if your body has a cancerous cell, so it carries a different wavelength than the normal tissue, right? So due to that, normally the cancerous cell are having higher range of the heat map, and then you will see that the color will be a bit red. So if you look at here, if I can draw from here, if you look at here, this is actually the black pixel. The black pixel, if you see the first one here, okay? This is the black pixel, okay? So meaning that black pixel meaning that it's a very dark pixel. The value is 0, and to the brightest pixel here, okay? So these images, the one that we always see, the colored images that we always see, the TV, in your phone if you snap photo, so it range from 0 to 255 here actually, 255 meaning that the allowable gray level value, so you have 256 colors from 0 until 255. So this is how it looks like, in ascending orders. So the 0 meaning that the color is black, and the 256, the color is the most brightest here, which is about yellowish color, okay? And how is that relevant in medical image processing? So this is the example of breast thermogram. So breast thermogram meaning that the image we capture using thermal camera. You will notice that the thermal camera, we do have a lot of thermal camera at hospital. Some hospital use it, and all I think almost all airports have this thermal camera. So if you are, especially during COVID, if you are having high temperature, your body heat map will be higher, okay? So using that concept, we already inventing this technology where we use a thermal camera to capture the breast area. If the patient has the cancer, the cancerous cells will cut, the color will be around red and all that, okay? If you have normal cell like this, so you will have like the first one is a normal breast, and the second one showing the suspicious different in the body temperature here. So here is, you see, this is a bit red area. So here is the suspicious cell that may include non-normal cell, abnormal cell, that may include the cancer. However, the breast thermogram is very suitable to be used as a rapid diagnosis, meaning that you just stand in front of the thermal camera, and perhaps if you are having suspicious heat map as shown in here, you need further checking. Okay, so the breast thermogram has been used in certain country actually as a screening before the patient do for mammogram. So I will explain in the class what does it mean by mammogram. Okay, so here is the another type of image. The top part is actually MRI image. The second part is actually SPET, SPECT image. And the lower here is actually the image that being registered. When I said image that being registered, meaning that we overlap these two images. That's the simplest way of explaining it. We overlap these two images to highlight the significant thing that is missing in MRI and that is available in other modalities. So when we overlap these two images, MRI and SPECT images, we can see that the area here is where the red area here is actually the prominent area that have the lesion in the skull. Okay, so this is another example, the holy grail of performing medical image processing. If we can overlap these two images, we can extract extract the information and leave it out things that is not that important. Okay, and you also will be exposed to the image segmentation. In the previous video, I already explained that you will do the image segmentation, right? So image segmentation in bahasa is called perluasan actually, where you put a contour at the area of interest. For example, for this case, we want the whole area here. So by having segmentation algorithm, we can instruct the computer to learn that this is the pattern that we are looking at. Okay, and this is actually a CT images, computer tomography images. Computer tomography images have many slices. If you look at one slice, you may not get the overall information. And the slices we have a lot of slices per patient, and it normally comes in the video format. So we want to tell the computer, if I load this video of CT scan of this liver area, for example, please segment this area. Of course, each individual has different size, but the size can be, we can put a range to the size for Asian, for Europe people and all that. So it's kind of the similar characteristic or the common characteristic, we can develop an algorithm so the algorithm will be able to segment it. All right, that is why we need to do image processing. So let's go to the basic part of imaging system. So the imaging is actually a 2D signal. The signal, the one-dimensional signal is what you normally hear from the sound. But the imaging system is a 2D or 3D images that you can see with your naked eyes. So type of radiation has many. The most four important are listed in table 1.1 here, where the electromagnetic wave will generate certain type of images, ultrasound coming out from the water, and also the other wave can come from the water, the ultrasound and all that could also produce an image. Okay, so this is the range of the electromagnetic spectrum, that some of it we cannot see, some of it we can capture, and some of it are available in using our naked eyes. Okay, so if you look at here, this is actually the cell, the bacteria and virus. So the bacteria, virus and the smaller cell, we can't really see in our normal naked eyes. If we can see, that will be better, you know, everyone will be health conscious, I would say, like COVID virus. If we can see where the virus go, I think by now we are still wearing masks. Okay, but that bacteria and virus, with the help of other magnification tool like microscope, we can clearly see how does it look like, what is the common characteristic of that virus and bacteria. All right, so this is the basic component of image processing system. If you flip through on the books, or if you find in the internet, it normally contain of this. The first part is the image acquisition system. What does it mean by that? By that is meaning that the image acquisition system is where you capture the image, where you collect the image. Okay, so either your phone, your digital camera, digital camera, microscopic camera, the camera that be attached to the microscope. If you've been to the tissue engineering lab where you do the pH experiment, I think you notice that there are few microscopes that attach with the camera on it. Frame grabber, image sensor and all that. Okay, and then we translate whatever that we capture there, we translate it to the computer format, yeah, and we use image processing software to process the image. It can be MATLAB, C programming, ImageJ, Python, Java, and so on and so on. But in our class, we will use MATLAB. Okay, so image is obtained in the form of electric signal, and this signal can be digitized into a sequence of number that can be processed by computer, because we want to tell the computer to learn it based on what we observe. Okay, our brain and our eye is very intelligent. We can differentiate between one person to another person, right? But when we want to tell the computer to act like us, we need to give an information to the computer. We need to develop an algorithm so that it has that information. It can be intelligent as human brain. All right. So this is how, from the analog format, it transforms into digital format. Okay. So you scan the image in analog form. What does it mean by that? Let's say if you want to enter university, you need to do chest X-ray, if you still remember. So you are the one that is physically, that is analog. You are not 1 or 0. You have a lot of things. The colors is different, the height is different, the weight is different, and all that. So we capture the image, for example, using X-ray, and that analog thing will be quantified in certain range of the X-ray size, X-ray image size, and we quantize it to become number. That number will represent a pixel, what we call a pixel in digital image processing. Okay, so this pixel can be manipulated, can be quantified, can be grouped together. If you group together, it becomes segmentation. Okay, so that it becomes a meaningful thing to the clinician, to the people out there to diagnose certain disease. Okay, so that's how it is transformed from the analog to digital. So each images that we see in the phone, for example, it has a number. So everything is a number. Okay, and in this class, this 14-week class, you will be exposed to this. The first 6 weeks, I think 5 or 6 weeks, we will do image enhancement, meaning that we amplify the signal of the image, we make it brighter. So it involves brightness adjustment, make it brighter. Contrast enhancement, contrast means between the dark area and the bright area, we adjust the contrast, bright and dark area, so that the image will appear as good as it seems. Why we need the certain object appear brighter than the other part? Because we want to segment it later on. Okay, image averaging, convolution, frequency domain filtering, and age enhancement. We won't focus much on this in this degree of degree medical image analysis for degree student. We focus on what we call time domain, or what we call spatial domain, or time domain. We do not convert it to frequency domain. And image restoration, meaning that we do correction, we do inverse filtering. And image analysis, this is what I mentioned just now. We do segmentation, we extract the features, we do the classification. And then we will look into the compression, image compression, where the good quality of image, of course, it has higher resolution. The kilobyte that it consumes also higher. But then again, if the image has very high, it occupied very high capacity, so it won't be fast to be processed. So sometimes we need to do the image compression. So we will tell about that. And image synthesis, where we look into the tomography imaging, 3D reconstruction and all that. For the last part, we won't be do the processing, but this is just the overview in this class. Okay, you will be exposed on the concept of like I mentioned just now, registration, the overlapping between two images, so that it will enhance certain features that we are looking at. Okay, not all images sorry, not all area in one image is important. Maybe we just want to investigate the lesion, for example. Okay, so the pectoral muscle or whatever area, we don't need it. Okay, so this is what we will look into for the rest of 14 weeks.